All right, this is where we left off, right? We were going to talk about implementing an array indexed bag. And because at the top of our class, we're going to specify public class array indexed bag, it's generic, it implements an indexed bag. You'll notice it doesn't say bag here, but indexed bag extends bag, meaning that this is both an indexed bag, and because it's an indexed bag, it's also a bag. So we've got that hierarchy thing going on. Yeah?
Would writing implement bag extend index bag work as well? Or
Implements index bag extends bag.
implement bag like it's written in the interface.
Well, the interface is extending the bag, but this concrete class is implementing the indexed bag. Like, I think I know what you're getting at, but I think you're thinking too hard. You're trying to, don't do that. Stop that. Remember, that's a common mistake of new programmers, of working too hard. Stop it. Programmers aren't that smart. We have to do everything one step at a time, because if it's more than that, we can't think about it anymore. So just take it easy. All right, so array indexed bag, what do we have? Well, when we go look at the various array-based things we've done, like a queue or the stack, what do we have? Well, we have this default capacity, a not found flag. There we go, some two constants for that. Do they need to be 100? No. Do they need to exist? Not really, but it just helps make the class a little nicer. Am I recording? Yes. And then other than that, we have our bag and our rear. The bag is generic type, its contents are whatever, and the rear is going to be just some integer. Remember, this is going to be basically the basis of this is going to be idea 1 for the array queue, which was the bad idea, but remember we talked last time, it is what it is. Every time we add and remove, it's going to be linear anyways, because we can add and remove to anywhere. We can't really take advantage of the fact that everything's always happening at one end or the other. Our default constructor, where we do the constructor chaining, we just do this here, but with the default capacity, we effectively call this constructor with 100 in here. Then we say, okay, otherwise initial capacity. Remember, we have to do that funny thing where we create an array of objects and then be like, okay, but trust me, they're actually going to be type T that I'm going to put in here. Okay? Rear, 0, an empty array for the start of our array index bag. Cool? Happy? Sad? Any thoughts, concerns, comments? Oh, by the way, just a reminder, and I brought this up in lab yesterday, but I'll say it again in case you know. If you know anybody, 161, 162 in the summer, they tend to be really popular. This year, for whatever reason, not yet, it seems. But because of it, there's always a risk of it not being offered. So if anyone you know might be wanting to take it, register now, not later. Otherwise, you might miss the boat, and it'll be sad. It's always a good time in the summer, though. Anyways, all right, cool. Now, note the import iterator at the top. It's not in here. If you were to go look at the class, you will see this import iterator. We're going to talk about this very shortly. Kind of did this in the lab yesterday, if you were here. An iterator is this fancy little object that's designed for nicely iterating over a collection. You can think of it as a stupid little robot that all its purpose is how to get from this thing to the next thing, to the next thing, to the next thing, and so on. That's all it can ever do. You want to go backwards, you can't. You can only go in one direction, but more on that later. Private methods we might want here, well, we've got a shift left and shift right. These ones are going to be handy for when we need to add something and remove something in the collection. If I want to add something at index 7, I need to make room for it, right? So I'm going to shift things to the right. If I remove something at index 14, I need to kind of close that gap, so I'll shift things to the left. That's the purpose of these two methods. They're private methods, they're helper methods. What are we going to do? Shift left. Well, from index start to rear, I go to index I. So what am I doing? I'm shifting left. This is closing the gap, okay? So this would be like the case. If I have like A, B, C, D, E, F, right? If I want to get rid of this thing right here, I have to shift left. I guess this would be my start, and the rear would be the next available spot, I guess. I say go from start to rear, here to here. I is I plus 1. Increment. I is I plus 1. Here, you'll notice that we actually don't go all the way to rear. We go to rear minus 1, right? You might say, well, in this case, if this is like null or 0, or it'll be null because it's an object array, you might want to do that, right? Go here and copy the null here, right, to close that gap. Makes sense, right? Because, I mean, effectively, that's exactly what I'm doing here. Why not just do that? Can anyone tell me why this might be a problem? Yeah. In the odd case, or in the off chance that if I try to go to like here, okay, I can copy H down. Oops, no, H stays there. I make a copy of it, replace it, And then I go here, and I go, okay, go here and copy the contents. Uh-oh, array index out of bounds. So that's why I never go to rear. Now, I always will put my finger on rear because each time in the loop I look at I and I plus 1, I plus 1, I plus 1, I plus 1, right? But I guess rear, the last thing where rear is 1 after the last, you know what I mean. But that's why we have to be careful about that edge case because otherwise things can crash. Similarly, okay, A, B, C. D, E, F. What are we going to do for shift right? From rear, well, I is greater than or equal to start, I minus minus. Ooh, well, okay, not too bad. So let's say I starts at rear here, right? And then copy over I minus 1. Well, that's this, F, E, D, and so on, right? Notice here that it's, well, I is greater than start, not greater than or equal to. As soon as I became start, I wouldn't want to copy that over anymore. Now, and then what, okay, the thing at start becomes null, so basically overwrite whatever in there. Presumably, if I am calling shift right, I'm going to be adding something to the index I'm making room in. So you might look at line 65 and be like, is that really necessary? Setting it to null. Because if I don't set it to null, this is what I would have, right? After I've made room, there's this extra D. I just copied D here, but I'm leaving it alone. Line 65 says, okay, replace that with like null, which I'm representing with the dot. So is it really necessary? If I'm shifting right, that means I'm going to be adding to that index. I needed to make room for it. I'm going to add to that index. So I set it to null. Then immediately I put whatever I want in there, right, x. So setting it to null is kind of unnecessary. Yeah, that's a fair argument. But you know how I am. Make my code as intentional as possible. What am I doing? I'm making room. So I've got room. Yes, I'm immediately about to override it, but make room, I'm making room. That's why I've done it this way. Both options would be fine, but I had to make a decision, and that was the decision, and that's why I made the decision. Iterator methods. Iterators are the folks for the next topic, so I'm only going to briefly talk about them here. This is what it would look like. Public iterator, its return type is an iterator of type T. It's called iterator. It's called iterator because it has to be called iterator. And it returns this new array iterator. And now you're looking at this going, what the hell's an array iterator? We'll get there. Yeah?
So does the first thing have to be an array, like in the array iterator?
We're going to define the array iterator. Oh. So this is not something Java gave us. We implement it. And so we define what these are going to be. Oh. You'll see. You'll see. Good question, though. Very good question. Add method. All right. Now, also, if we go back here, does anyone have any other comment about shift right? Yeah.
If you start at
Index 0, I starts at 0, well, I is greater. It wouldn't be a problem because if I starts at 0, then we immediately ask, hey, is 0 greater than 0? It wouldn't, that shouldn't be a problem. What were you going to think? Yeah, if it's full, we might have an issue, right? What if I have C, D, E, F, G, and I say shift right? All right, go to the end and start moving things down. Uh-oh, we got a problem. You're absolutely right. This would be a problem. And this is perhaps, I don't know, first of all, you can see what I'm doing here. This method assumes that there is room in the array to facilitate shifting. So that's why I'm assuming there's room. And you might say, but what if there isn't? You're right. I don't have any logic in this function, or in this or in this method, to account for that potential problem. But in my design, my add is going to say, if there's room to add something, or let me reword it. If there's no room, because look, if I want to add something here, is there room? No. We'd have to expand capacity. So I will have expanded capacity if there's ever the case where there's not enough room in the array to add anything. That would mean there's not enough room in the array to shift anything. If that's ever happening, I'm going to expand capacity first. That's what's going on here. Then I shift right. So there will be room. It should never be possible to call it if there's not room. You could make an argument that like, maybe you should really deal with that in the private method, and that's a reasonable thing to say, but it's also not unreasonable to just do it what I've done here. So add, remember we had two adds. There's the add, this is the override from the beg interface, where it just add. Where are we going to add? We decided, like we talked, where it makes sense to add. If we ever call add and we don't specify an index to add, it's like append. Add it to the end. So what are we going to do? We're going to return the result of calling add, this one, the one that takes two elements, the one that specifies an index and the element. Well, what in the rear? So if I ever call add without an index, it just calls the add with the index, but it gives it the index rear to add it to. Cool? Yeah. But then there's the more general add where you specify the index. Well, what do I say? Okay, index size is oh yeah, this is a good one. So I've got some error checking here, bounds checking, where I say, okay, if someone specifies an index less than 0, you can't add it there. If someone specifies an index that's too big, you can't add it there. However, it's possible to specify an index like here, you would say, well, how big is this array? Or how big is this list? 1, 2, 3, 4, 5, 6, right? So if you were to say index, okay, 0, 1, 2, 3, 4, 5, 6, you might be tempted to say, that doesn't exist, but we're adding. And that last spot is actually valid. You can add to the next available spot, effectively. So that's the one little peculiarity there. That's what that comment is. Index of size is valid because that's like the appending. Otherwise, if it's an issue, index out of bounds, the message is just whatever, index. So it would be like index out of bounds, and then it tells you the index. Then I say if size is equal to the bag length, we're out of room. We'll have to expand capacity. Now, you'll notice here, I didn't use an expand capacity method. Why? Because I believe in y'all enough now that we can make use of a built-in method that does this already. In fact, it's a built-in static method from the arrays class. There's a method inside the arrays class called copyOf that, given the thing and some length, it'll make a new array of the specified length of a copy of that thing, kind of padding it with empty spots. It's doing expand capacity for us. All right, so instead of writing our own expand capacity, we'll just use the arrays.copyof. There are variations of this that you might find kind of neat. You could specify, make a copy of, but only between this index and all these other funny things. There's a lot you can do, and there you go. You may notice there is a similar method here called, do I mention it? I don't think I do. There's a similar one called like system.arrayCopy or something. Don't use that one. You can, but don't, because that one is side effecty, where this one is a nice pure function. Okay? It just returns a new array. Great. That's it, right? It's nice and pure. The other one, you'd have to give it an array and you make a copy. It's a whole thing. Yeah. Okay. Yeah. So this is the better one. Does it really matter? No. But does it matter? Yeah, use the good one. Yeah. Use the pure one. Given a choice, use the pure functions, right? We like that. Side effects, ugh. So if we're out of room, expand capacity, but we're doing it with the built-in static method from the arrays class. And then what do? We shift right to the index to make room, add the thing at the index, increment size, return true. Cool. This can only ever return true. That means this really could only ever return true, but we just relay. If you ever call this method, it calls this one. This returns a value true, which then this method returns a value true. So we just, relay some information around. That's all. Cool? I think that's cool. So the add element simply delegates to the other one. Unlike the methods for adding in the stack queue, the method may throw an exception because the specified index could be a problem. Like the stacking queue, we may run out of room. We didn't use expand capacity here. We used copy of. This creates a new array with a specified capacity and copying the elements in order. Cool? Cool. Shift right, that private method we already looked at. Any questions about this add? I don't know about you, but I find this one, like this add right here, to be a really good example of, like, chances are, if you've made it this far in this class, when I've talked about this add to an index list, and I say you specify an index, you know what needs to get done. You're like, oh, I'm going to have to make room. Oh, I have to copy things over. You know that, right? You know that. But I find this is one of the first examples of like, okay, we've got a method that can deal with this this overflow. We built a method to do this. By including additional methods that abstract some functional unit, like just shift right, make room, add it. Like this becomes so much cleaner and clearer. Like if I had to include the logic shift right into there, look, it's not crazy complicated, but I think if you put that like this plus that is complicated. But calling shift right, it's, oh yeah, okay, shift right, cool. Right? Exactly, right? Like I find this to be such a clear example of like, look at this. By just taking the time to abstract some logic, that's not complex logic in and of itself, but it's its own like unit of logic that can be separate. That we can make use of. I just find it so nice.
I love a good private.
Right? Like, oh, there's something about it, right? Yeah, exactly. It's so much cleaner. And it makes this code, like, it makes this, like, you look at this and you're like, yeah, that is simple. It's simple because we kind of offloaded the complex bits, but there's just some cases. If you don't have room, whatever, you shift right, add it, you're done. Similarly with the remove. We have remove at an index. Well, if the index is out of bounds, you raise an exception. Otherwise, get the element, shift left, rear, decrease, return the element. That's all. It's nice, I think. I think this is really nice. And then we have that other remove, where we don't specify an index, we specify an element. So the one where we specify an index, this was the remove defined in the indexed bag interface. This is the remove defined in the bag interface. So we remove from two places, similar like with add. This was from the regular bag. This is from the indexed bag. So what this one's going to do? Well, this one kind of just does what we just did, but it does a little bit of extra stuff. We're going to call this contains method that we haven't written yet, but we'll write it in a moment. Contains, it's going to return true or false, whether or not that element even exists. If it doesn't exist, return false, right? It doesn't exist. Can't remove it, fine. You might say, should it maybe raise an exception? Exactly, like, well, now we're coming into a design decision. And to conform to like the collections, you add something, you try to remove something that's not there. This is a little different than like popping from an empty collection. I'm saying remove a specific element. Well, I can't, that element's not there. It's not like I'm removing from an empty thing. It's a little different. So, contains, if it's not there, return false, yeah.
Yeah, like it's the difference between saying I can't remove period versus I can't remove that.
Yes, right? So like there is a difference. There is a method to the madness. We could sit down if we wanted and probably talk for the next half an hour about the pros and cons of these different design decisions and why it might be better one way or the other. We could. At the end of the day, we're not gonna. So it is what it is, all right? So this remove this element. Is it not there? If it's not, we can't. Otherwise, find the index of that element. Again, this is a method we haven't written yet, but it's a linear search. Contains. It's a linear search. I think contains actually uses index of, but otherwise, just call remove of that element. But I'm calling the remove that takes an index, right? Now, you might notice this remove returns an element of type T. I am completely ignoring that here. I don't care. It gets lost to oblivion. This returns the element and it goes nowhere, so it floats away. And then I return true. Why? Because this remove returns a Boolean. If you remove a specific element, it returns true or false. If you remove something at a specific index, give me that thing at the index. Why? Because. Yeah.
Because if you're removing a specific thing, you already know what the thing is.
Exactly. I don't need reference to it, right? Like, remove this thing. Well, I have a copy of that thing. Remove the thing at that element. I don't know what it is. Give it to me. So there is method to the madness. You're right. Good job thinking on that one. But, yeah, there we go. So delegates, an index of will throw an exception if the element does not exist within the bag. Ah, yes. So index of throws an exception. But this should never throw the exception because if it doesn't exist, we would never get there. Right? You see? Yeah. I should probably add a note to that. It's not, however, that like a note saying like, but that would never happen based on this code. Okay. Now, I didn't show you all the methods. You go download the class that I wrote, you'd find all the methods in there. The things like contains, index of, and whatnot. But they should be pretty straightforward for you. Just linear searches. Now, if we had array sorted bag, let's say we were going to start thinking of like remove first, remove last, first, last, but we know add and remove have to be done in a certain special way. So array sorted bag. Again, like I said before, we're only going to include specific ones to discuss here. How do we start this class? Public class array sorted bag. Weird crap going on here. Implements sorted bag. All right, but what's going on here? Well, the thing of type T has some conditions. If it's a sorted bag, because the elements themselves determine the ordering. The sorted bag's job is to make sure the things are in their ordering, but the elements themselves have the ordering of, like, associated with themselves, like integers. Integers define their own ordering. So the elements that I'm adding must have an ordering defined for them, and that's what that is saying there. It's type T, but there's a rule. There's some constraints on the type T. Other than that, capacity, not found, bag, rear are two constructors. Now this one's actually kind of funny. You'll notice the type of the array I'm making is not object. It's comparable. Because again, it can't be an object. I can't cast something of type object to something of type T because something of type T has to be comparable. An object might not be comparable. So, yeah.
Wait, so could you like so you have an object, you cast comparable onto it, and then you can cast type T onto that?
Maybe. I don't know. Don't.
Don't.
Do it the good way, where it's like, well, look, I know they have to be comparable. But I like what you're thinking. A good computer scientist always goes,
How can I break this?
yeah. If that's true, can I do this? It didn't say I couldn't. Yeah, that's usually how you do it, right? If your mind goes there, that's good. Keep up the good work. All right, so notice T extends comparable, super T, what's that? Well, it's a little bit to unpack. First, when something extends comparable, it means that that type has some defined ordering for it. It means that there must be a method inside of the class that defines this type. The method is called compareTo. And that means that that class implements or extends. I can't remember if it's an interface or a class. But it's going to be implementing something. Like it's going to create that contrast. Let's assume comparable is an interface. Is it an interface? Or if it extends, it's probably a concrete class. No, it's an interface. OK. Comparable. If I have a class that implements comparable, that means that this method must be implemented. Other methods can exist, but like a queue, if you implement a queue, you must have certain methods. For the comparable, this is the only one that we have. And this has very special rules on how we'll use it. Basically, it's a method where I can ask an object of the type, hey, x compared to y. And it's going to return either a positive, a negative, or a 0 value. If it's 0, that means they're actually equal. That means if you said, hey, dot equals, x dot equals y, you should get true. If you get a negative, that means x is less than y. It should come before the y. And if you get a positive number, it should come after the y. Now, I believe technically, by the way, the rule for this is based on the ordering, usually all that matters is it's a positive or a negative. However, if you go and you actually look at implementation in Java, you won't just see positive or negatives, you will see like an actual like difference. So for an integer, it would be like, hey, if it's like, hey, 5.ct7, right? And what that would give you is probably like a -2. Why? Well, it's negative, 5 comes before the 7, but it actually gives you a little bit more information. That's helpful in certain cases. We're not going to worry about it too much, but if you do go and look at the implementation, you're like, it's not just returning a positive or negative, there's more information there. Yeah, but not overly important for us right now. But interesting either way, I think. So when something extends comparable, it means that this can be compared to some type T. All right? T extends comparable T means that the type T can be compared to things of type T to provide some defined ordering, which is needed if the elements are to be sorted. Thus, this means that T must have a defined ordering for itself through either a direct implementation of compareTo or some superclass inheritance nonsense. Long story short, it's the magic code that you need for these ordered thing. Okay? The details and nuance of this are not something you would even really care about too much in your CS degree. It's not a computer science-y thing. This is the Java code to be like, here's how you ensure it's ordered. Okay, that's a Java thing, not a computer science thing. All right, so add. Okay, well, add. If we don't have room, make room. Otherwise, call this fancy method find insert index. All right, it's just going to be a linear search. Shift right at that insert index, add it, increment rear, return true. Another example of what I think is, like if you were thinking, at this stage you are definitely capable, if I said write a single method, don't do any fancy helper methods, write a single method to add to an ordered, sorted array index bag, you could do it. You can't use an expand capacity, you could write all that logic out. But look, if I'm out of room, expand capacity. Find where it goes. I could write the logic to do that, or I could call a method that does it, and look how much cleaner that is. Shift right, add it, increment, return. It's so much clearer with nice, good, high-quality code. Have nice, good, high-quality code. Because then you get this, I don't know, there's like a beauty to it. There's an aesthetic, I think. Right? If you can't see the beauty in like nice code, I feel sad for you. Right? There's something about it. You know, it's art. All right, so what is find insert index? Well, that's not too bad. But what is all this weird stuff going on here? Well, look. Find insert index of the element. Search index 0, for t, bag element, this, what? I know. This is where that iterator thing comes in. And that iterable thing comes in as well, which we're going to be talking about shortly. All this is a loop that starts at the beginning and goes to the next thing, into the next thing, into the next thing. Okay? This is a loop that might look more similar to what you're used to in Python for each thing in the collection of things. In this case, the thing is the bag element. That's the label I've given it. But unlike Python, I need to specify the type. What's the type? T. Really, it's like a comparable, but that's already constrained up at the top. So the generic type and the collection of things. Now this is weird. This is weird because you might be like, well, the collection of things is the array. Yeah, but no. And this is all going to get sorted out when we talk about iterators and iterable. But first and foremost, an array is iterable, meaning you can do that, right? But I didn't put the array here. I didn't put the bag array here. I put this. And what is this? This is this class. We are going to make the bags themselves iterable. I will show you, I will make this clearer as we go. But basically, what do I want to iterate? What do I want to iterate over? Myself. Now, you're going to say, well, but all the contents are in the array. Yes, but an iterator for an array would iterate over all of the indices in that array. 1, 2, 3, 4, 5, 6, 7. The bag should only iterate over 1, 2, 3, 4, or 0, 1, 2, 3, whatever. Right? So there actually is an important difference here. You are not to be looking at this thinking to yourself, I understand completely now. No, you're not. I'm going to show you, I'm going to make this more concrete in a moment. But I'm just kind of teasing some neat, fun stuff. This is all enabled by Java's interfaces and the design of Java and good design code. So I'm kind of throwing you into the deep end, but I'm going to throw you a lifesaver in a minute. I want you to try to swim a little bit. Okay? All right, so what's going on here? For each thing, okay, so I've got the element I want to add. And I say, okay, hey, element that I want to add, compare yourself to the current thing, the bag element. If you are less than or equal to 0, you go there. Return the index done. Right? That would be like saying if I have like 5, 7, 11, 14, 15, right? I start, and let's say I want to add, give me a number less than or equal to 5. 3. Perfect. I love it. I go 3. Hey, 3. Compare yourself to 5. If compared to gives me a negative, that means that the left-hand side, the element 3, is less than 5. And if it is less than 5, it should go in front of that thing. You'll also note, you might say to yourself, shouldn't I just check less than? Because there's nothing saying, can you see this decently here? There's nothing saying I couldn't have duplicates, right? So if I want to add the number 5, where does it go? According to this, where would the new 5 go? Right here, right? Now, we could really take a moment and think about this. These elements are equal. Does it really matter if this one comes before this one or not? It kind of, maybe it really depends. Really, for me, when it comes to a priority queue, which I hope you see the similarities between a priority queue. A priority queue in and of itself is first come, first serve. But it's, the priority first. But then to me, it feels like the second ordering is well, who was there first? Where in this case, the new thing went in front, and you're like, well, that's not fair, right? But should that matter? Maybe it doesn't, maybe it does. It all really depends on the definition of what we want it to do and how it should operate. Here, we don't specify, so it doesn't really matter. If here I said strictly less than 0, what would happen? I would say, does 5 go before 5? No. Does 5 go before 7? Yes. And then it would go here. And then fine, okay, great. But the equal to is fine. And I want to emphasize something really big here. Let's say I'm adding the number 8, okay? Does 8 come before 5?
No.
Does 8 come before 7?
No.
Does 8 come before 11? Right, so I know 8 must at least come before 11. But I literally just, on the previous iteration of the loop, concluded that it must come after 7. So it's safe to say it goes right there. Right? A lot of people, to me, I find it obvious, but every year someone asks. And it's fine to ask because your mind's thinking, you're right. But in the broader context, we know it goes where it goes. As soon as I say, hey, does 8 come before 11? Yes, it could come anywhere before 11. But I did just conclude that it must come after the previous element. So because it comes after 7, but before 11, it comes between the two. Remember that. So that's what's going on. And let's do the other extreme case. Let's say I'm adding a 77. Does 77 come before... does 77 come before 5?
No.
Does it come before 7?
No.
So increment search index. Does it come before 11?
No.
Increment search index. Does it come before 14? 15? Oh, well then it must, we increment and then we're done the loop, return the rear. It must be the end. Now in this case, rear and search index would be the same, right? Actually, yeah, maybe it's worth pointing out. Notice that I'm not using search index to index the bag. I'm not using the search index, this is an integer. Starts at 0, then it becomes 1, then 2, then 3, and then 4, and so on. So I'm not using search index to index the bag array. I'm just using the fact that this iterator gives me each element in order. The value of having this search index here is because, well, that's what this is supposed to return. So I need to know where it is. If you look at this, it's like, look, let's say I get down and I'm at 0, 1, 2, 3, 4. 4, right? So let's say search index, it starts at, okay, 0, no, 1, 2, 3, 4, okay, 4. We just finished saying, hey, does 77 come before, does 77 come before 15? No. Increment search index becomes 5, right? Then we go, oh, we're out of elements. So we jump down to here. We're on lines 15, 16, whatever. The value of search index and the value of rear must be equal at this instant, right? Right? Now, again, it always comes down to this. Why did I pick rear? Why didn't I say search index? Both are valid. One's not more correct than the other computationally, effectively, but why did I put rear there? Well, can anyone guess why I put rear? What do you think?
Rear makes more sense.
Yeah, I think it's like, why? Well, return the rear because it must be at the end. And what's the end? Rear. Search index is also the end. Yeah, but that's a little more obvious to me. If you did one or the other, it doesn't matter. It won't matter. Saying search index, if you're like, no, it needs to be search index, and I'm going to write you a book on why. Fine. Fine, more power to you. But that's why. I just don't want you looking at this being like, what? Why? Is that meaningful? Functionally, no. Design and code readability, yes. In my opinion. But does it really matter? No. If it, at any point, it feels a little bit like, man, he really talks about like why he used one variable name over the other a lot. I do. But I really feel that if you're the type of programmer that's taking the time to really think about that, overall, you're a far better programmer than someone that doesn't. And you might be like, but I'm spending so much more time. No. You're spending more time thinking about that, but you're probably spending less time overall because of your understanding of what you're doing and other people's understanding of what you're doing as well. This is so important. Getting it right is one thing. Getting it right and good is another. So yes, I do spend time on this. I used to not. I used to be like, yeah, that was, no, listen to me now, trust me. Be intentional. If you're intentional with your code, that means you understand your code. If you understand your code, you're in great shape. All right, so compared to yada yada, since T, yeah, okay. A linked implementation. We can make a linked implementation easy peasy, like you started to in the lab yesterday, right? Right. Cool. Any questions? Who's been reading through the textbook, by the way? There's a text.
That's so real. That's real. So
Of course there is. Jeez. Yeah, it's not a free one like last semester. Yeah, there is. Yeah.
I didn't know that.
So, by the way, just as a note, the textbook for this class, which at this stage I would not say go buy it, right? You know, look, it's great, right? It really is. Now, as a note, if you're going through the textbook and my slides, my content, you're going to notice differences, how I implement things a different way. And there's a reason for it. It's because the people who made the textbook code this is better. It really is. But it's based on the textbook. I'm following the spirit of the textbook, okay? And seeing multiple implementations of the same idea, big deal. That's very good. The core concepts are the same. Specific implementation details, those are implementation details. So there is a lot of value in those differences, by the way. All right. Iterators. Give me a second. I'm very thirsty. I can tell when I start spitting a lot. My mouth is drying out. Do you have any questions while I take a drink of water? Everyone's happy? Good. All right, iterators. We've iterated over all the collections so far. The containers, the collections. We've iterated over arrays, link structures. We might want to iterate over stacks, queues, bags. Now you might say, you're not supposed to access anything stack, queue. Yeah, but think of like the toString, right? We iterate over it. It's normal. When we go through and put our finger on each thing as we go, that's called iterating, like, right? Iterating. That's what it is, right? And there were some common patterns for iterating that we followed. Like, here is the common pattern for iterating over an array. This will do everything in the array, including things that may or may not be there to the full length of the array, but that's the general pattern, right? I from 0 to wherever we want to end, increment I, some process on some array at index I, right? Right. However, not everything we might want to iterate over is going to be an array. So like this for loop is fantastic for an array. For loops, yeah, we can make them work for a link structure, but as we saw, like while loops are a little nicer for link structures. While current node reference is not null, do something, right? Like this, right? This is the general structure of iterating over a link structure. While the current node is not null, go do something on the data from the current node. Current node equals current node's next. There. Repeat. So this is the general structure of iterating over a linked structure. Neither are overly complex, but I can't help but look at this and say like, well, they're different though, like wouldn't it be great if there was a common way to do, like I just want to iterate over something. I don't want the way I iterate over something to depend on the underlying container. That's where iterators come in. Now, we're going to be talking about two very related but separate things. Iterators and iterable. An iterator is a little robot that goes from one thing to the next thing. Iterable is a collection that you can iterate over that has a little robot that can do the thing, right? So they build on one another. So Java provides a common, uniform way to iterate over things. Not just Java, a lot of languages do. Iterators are objects that allow iterating over some collection one element at a time. Now we have to define how it's done, but that's what it is. The purpose of this is going to be like with like interfaces and whatnot, where like if you implement this interface, I know you have an iterator. Or if you implement this interface, I know you're an iterator. And if you're an iterator, I can use you wherever I use an iterator. That's kind of the idea. How you do it, you have to write, but if you implement it, I know you're an iterator. If you implement it correctly, but yeah. So there are two important relevant interfaces, iterator and iterable. The iterator interface, that tells us that the object, so when we make an iterator object, if we define an iterator object, it's going to be a hilariously simple class that we're going to implement. To define an iterator class, we are going to implement to define a class that it has an iterator, it needs to return, okay, I'm getting ahead of myself. If I want to make a class, if I want to define an iterator, I implement iterator, okay? That's how I'm going to do it. And we can go here and look at the iterator interface. There it is, there. And you look, there are 4 methods in here, okay? We need to implement actually only 2 of them. These 2. These are the methods that we're going to be forced to implement if we make an iterator. I'll talk about them. The 2 abstract methods we have to include are going to be next and hasNext. Next returns the next element. So in the case of an array, if I have like A, B, C, D, E, this is my little robot. It's a little car robot. Okay? It's starting at the beginning. If I say, give me the next thing, people might get weirded out by this because it's like, the next? Is that the next? Well, no, the next thing is like, it's kind of like, is it this Tuesday or next Tuesday? Well, which one's this? It's that same problem, okay? Give me the next thing. That's A. And after I get it, this little robot moves such that it's here, right? HasNext, yeah, B exists. Give me the next thing. Okay, it gives me B now, and then it moves on down to here. That's the idea of the iterator. Now this is the array idea. You could think of it the same idea as a link structure.
Do we have a name for the robot friend?
Itty.
Sure.
Yeah, makes sense. That I just made, that's not a real thing,
No.
but it should be. So here's my little robot. It's here, right? Give me the next thing. Well, that's A. Now you go to the next. Give me the next thing, B. I'm asking this robot, give me the next thing. The robot's dealing with how do I move over the underlying collection? Is it an array? Is it a link structure? That's the robot's problem. I just say, hey, is there another thing? Give it to me. That's what hasNext is. It returns true if there is another thing. If it returns false, well, it's at the end. And then it's done. It served its purpose. It's dead now. After, well, there. Now it's dead. No, well, it served its purpose.
Does it have to retire?
Fine. It died in ecstasy. Sorry. It was so happy with itself. I've served my purpose. There. All right. So with this idea, this is what we get. So imagine I have like an iterator from this arbitrary iterable thing, .iterator. Remember, the bags had a method that returned an iterator. So imagine I had my bag .iterator. It gives me back an iterator. So I say, well, iterator hasNext. Do the process on the next thing. Repeat. Whenever I call next, by the way, it gives me the next thing and sets itself up such that it always is ready to give me the next thing. So there. When I say give me the next thing, it gives me A, but it also moves on down to there. Yeah?
I'm going to ask, if the implementation for iterator has other functions than those two, then how come you don't have to implement?
I'm guessing they are, maybe there are concrete ones that you'd have to like override or something. I'm not 100% sure. I don't know offhand.
I mean, they have the keyword default.
Default, maybe that's what it, maybe that's what default. What is it? What does default mean? Maybe it tells us something here. Has next, next, removes implementation. So it's got some implementation that you can override, I guess, where it just says like, I don't do anything. I don't know. Let's not worry too much about it. Yeah.
The first next, it acts as an A instead of like.
Next would be like, all right, give me the next thing. It's like saying, imagine you show up to a line, and there's a line of people at Starbucks, and I say, next. Who at the person at the front, you might be like, well, they're the current. No, they're like, for me, they're the next thing. Yeah. It's like, again, like I said, like, next Tuesday. And you're like, well, is that the Tuesday coming up or is it the Tuesday after? Because this Tuesday, maybe that's the, next is like, who, if I just say next, who comes? Hey, that's the idea. But we're out of time, but we'll leave on here, we'll pick up here Tuesday.